this lesson we're talking about absolute value equations. So basically, if you see absolute value with an equal sign, that's the type of problems that we're talking about today. Okay, so like here. Now notice, some of the problems have stuff outside of the absolute value, like on the second page, there's all the numbers outside, whereas the first page of the notes only has stuff, and when I say outside of the absolute value, I'm talking about on the same side, so I'm kind of drawing a line to show the left-hand side and the right-hand side. So notice here, we don't have anything outside the absolute value. Same thing here, nothing outside, everything's inside. Same thing here, nothing's outside, okay? But on this side, sorry, the blank sheet, like a number 11, you have a 2 outside. Here you have a 6 multiplied outside. Here you have a +1 outside. Here we have subtracting 6 and multiplying by 7. And there's other things outside, okay? So when we talk about isolate the absolute value, well, numbers 1 through 10 are already isolated. So isolate basically means that nothing is outside of the absolute value on the same side, okay? So I actually want to look at these problems first, okay? So when I say you must isolate, okay, remember we said, well, okay, here's a good question. What if there's stuff outside the absolute value bars? You must isolate. Well, what does that mean? You have to get rid of the stuff outside the absolute value bars, and then basically it's kind of like solving equations because you have to work backwards. Okay. So like number 11, again, I'm going to draw this line because I only care about the left-hand side right now. This +2, I need to get rid of that because it's outside the absolute value. So I'm going to subtract, I'm going to undo it by subtracting 2 on both sides. So then I get the absolute value of C equals 10, okay? And I'll talk about what that means in a second, but let's practice some more on isolating. So on number 13, again, I'm just drawing this line so that you can see I'm just working on the left-hand side. That's all that I care about. I need to get rid of the 6 that's outside the absolute value. Well, remember absolute value are grouping symbols, and so anytime you have a number next to grouping symbols, that means multiplication. So to undo it, we need to divide by 6 on both sides, so we get the absolute value of x equals, I almost said 3. My brain is not working. 4. Okay. Now let's look at 15. Again, I'm going to cover up the right-hand side. I only care about what's outside on the same side as the absolute value. The only thing I need to worry about is that +1. As soon as I get rid of that +1, we say that the absolute value is isolated. That's how we isolate it. In other words, there's nothing outside. There can be lots of stuff inside, but we don't care about that yet. So to get rid of that +1, we're going to subtract 1. Okay? So then you have the absolute value of 2w minus 4 equals 8. Okay? Now if you look at number 17, again, we don't care about the stuff on the right-hand side. We only care about the stuff that's on the same side as the absolute value. So in this case, it's the left-hand side. Now notice we have a 7 in front of the parentheses and a -6. So when we're working backwards, when we're solving an equation, we need to work backwards on the order of operations. So we have to undo all the adding and subtracting first, and then undo all the multiplication. So we have to add 6 on both sides first, and we still have this 7 times the absolute value of 4n plus 8 equals, and then this will be 112. Now, just like we did up here when we had a number next to the absolute value, to get rid of it, we did the division. We're going to divide by 7 on both sides. So now we get the absolute value of 4n plus 8 equals, well, okay, 112 divided by 7, that's 16. Now, what do we do once we have the absolute value isolated? Okay, well, let's look back at these steps. So, step 1, anytime we have absolute value in the equation, we want to make sure that it's isolated, okay? That's what I just did on numbers, whoops, I keep forgetting that, thanks, numbers 11 through 17, okay? Now, the next step, it says set the inside equal to both the positive and negative number from the other side of the equation. Okay, well, let's talk about this for a second, okay? This is key. In fact, all absolute value equations, unless it's set equal to 0 or there's no solution, which you'll learn more about in algebra, no solution, which you'll learn more about in algebra 2, have a maximum of 2 solutions, okay? So for algebra 1, basically when we have an absolute value equation, you're going to find 2 solutions, okay? Well, the reason why we set the inside equal to both the positive and negative number on the outside, okay, you got to think about, first of all, the definition of absolute value. It's the distance a number is from 0, okay? Well, the number outside is the distance, okay? So if I asked you, well, what numbers have a distance of 2 units from 0, well, you would tell me both 2 and negative 2. That's where set the inside equal to both a positive and negative number from the other side of the equation. Because, again, the number on the other side of the equation tells you what the absolute value is. And there's always 2 numbers that have the same absolute value or that are the same distance from 0, okay? So up here at the top, I want you to make a big note. There's always 2 numbers with the same absolute value, okay? So in other words, if I set the stuff inside, well, the stuff inside is just x equals to negative 2 or x equals to positive 2 because, so in fact, these are our solutions, but I'm just going to show you the because, that's my B/C, because the absolute value of negative 2 equals 2 and the absolute value of 2 equals 2. Because I could plug in, I could replace negative 2 for x inside and I still get an absolute value of 2 outside. I could replace positive 2 inside and still get an absolute value of positive 2. You don't have to do this every time, but that's why you do the inside equal to both positive and negative number from the other side of the equation. Now, I wanted to show you this on one of the harder problems for a second. So let's look at number 17, okay? I'm going to use the summary space because I write big and I'm going to run out, but you will have to do the summary at the end, summarize the steps in your own words. I'm going to be looking for that in your notes. But I'm going to use this, in fact, here, I'm going to use a sticky note. Okay, I'm just going to use this space. So the stuff inside, I'm going to set to both the positive and negative of the number on the other side. So I'm going to set 4n plus 8 equal to negative 16, or the 4n plus 8 is going to equal the positive 16. Now, just as a good habit, especially when we start getting into compound inequalities, since the negatives are on the left side of the number line, so if I drew a number line and here's 0, we know that these are the negative numbers that go down to negative infinity, and we know that's to the left. So I always put the negative number, or I call it the negative absolute value boundary, on the left, and then we know on the right of 0 are all the positive numbers that goes on to positive infinity. So that's why I put the positive boundary of the absolute value on the other side. So now we just solve, and you're gonna get two, even though the stuff inside just equals the positive or negative, the two answers that you're gonna get are gonna be completely different, okay? It's almost like solving equations, like equation inception, where you have an equation within an equation, okay? So then when we go ahead and solve, we just subtract 8 on both sides, on both equations, and you can draw a line if you still need that to show the left and the right-hand side. So we get 4n equals, and this becomes negative 24, or 4n equals positive 8. And we divide by 4 on both sides, and we get n equals, well, this becomes a positive, or sorry, negative 6, because negative divided by a positive is negative, or over here, n equals positive 2, since 8 divided by 4 is positive 2. Okay, now if I plug these two numbers into the original equation, and then I do all the stuff outside, after I take the absolute value, it's going to equal 106. Okay, I'm not going to spend time doing that right now, and I'm kind of working backwards on purpose. I want you to see what the harder problems look like, because sometimes if I show the easier problems first, I just get two answers. Like, people will just give me negative 16 or 16 and they won't do the rest, and that's a problem, okay? Now, if you look at number 15, remember we said step 2. Oh, by the way, I was going to show you this. After we set the inside equal to both positive and negative number from the other side of the equation, we solve both equations, okay? We solve both equations. Then step 4, write your answer as a solution set. These curly brackets basically means the set containing. I forgot to put that. So down here we'd say n is the set containing negative 6 and 2, because these are the possible solutions, okay? Sorry about that. So, like number 15, step 1, we isolated it. We got rid of the stuff outside. Step 2, set the inside, okay, the stuff inside. So the 2w minus 4 equal to the positive and the negative of the number outside. I'm going to put the negative 8 first, or 2w minus 4 equals positive 8, because I just want to keep reminding myself that negatives are on the left in the number line and positives are on the right in the number line. And now we just go ahead and solve both. Well, the steps are going to be the same, but you're going to get different answers because of the different signs on the other side, on the right side. So we add 4 to both sides. So here we get 2w equals, this is negative 4, because there's more negatives, and 2w equals 12, because they were both positive. So we divide by 2, and I notice negative 4 divided by 2, well, I'm just going to go ahead and put my solution set. So w is a solution set containing negative 2 and positive 6, and we already have the answers in increasing order from least to greatest, and that's how we set it up with our negatives on the left and positives on the right. Okay, so now I'm going to go back to number 9 and 7. Okay, we don't have to do step 1 if there's nothing on the same side. See how if I cover up the right-hand side of the equation, there's nothing outside of the absolute value. Same thing here, so I can skip step 1. So I go straight to step 2, and I'm going to do that on number 9. So I'm going to set the stuff inside. So 4n plus 2 equals negative 34, or, and I write big, 4n plus 2 equals positive 34. And then I'm just going to solve both. And again, I only draw these lines to make the left-hand side and the right-hand side clear. You don't have to do this, but if this helps, keep doing it. So I'm going to subtract 2 on both sides on both equations. And even though the steps are the same, I'm going to get different answers on the right-hand side. So 4n is going to equal negative 36, and 4n is going to equal 32. So I'm going to divide by 4, and I can set up my solution set. N is the solution set containing, well, negative 36 divided by 4 is negative 9, and 32 divided by 4 is positive 8. So those are my two answers for N. Okay. Same idea for number 7. I take the stuff inside, D plus 1, and I'm going to equal to -8, or D plus 1 equals +8. Now I just need to solve, so I subtract 1 on both sides. So D equals -9 or D equals 7, and basically that's my solution set. So I just put -9 or 7 in the curly brackets because that tells me the solution set, or the possible numbers for D that'll make this absolute value equation true. Okay. Now, all right, let's go back to the easy ones. Like number 1, there's nothing going on inside. So basically I call these like mental math type problems. Like what two numbers have an absolute value of 11? Well, I can say K is the solution set of -11 or 11 because those are the only two numbers that have an absolute value or a distance of 11 units from 0. Now number 5, I could do a mental math as long as you remember the positive and negative, or if we'd go ahead and do step 2, do the stuff inside, so 5z equal to the positive and negative number outside. I'm going to put the -40 first, or 5z equals +40. So I divide by 5, and I get z equals, and I'm just going to put them in my solution. Sorry, my curly brackets aren't the best. I don't care. If you don't know how to do it, just do a wavy line. It's good. I'm not going to grade you on your ability to make curly brackets or braces. So -40 divided by 5 is -8. 40 divided by 5 is +8, and there's your solution set. Okay, so yeah, number 1, the proper answer would be the solution set of -2, 2. All right. Now, in a second, I'm going to have you do the evens on your own. Let's go back to 11 and 13. These I would call the mental math algebra or absolute value equations. So C is just going to be the solution set -10 and 10, because there's nothing when you have a variable all by itself inside. The positive and negative of the number on the outside are basically the solutions. Same thing with number 13. So X is the solution set of -4 and 4, and we're done. Okay. So now I want you to do 12 through 18, and then obviously 2 through 10, and then look at the answer key at the end and bring any questions to class. Make sure your notes, you have this summary in full sentences, putting these steps in your own words, okay?